afternoon.
Good afternoon, Cerise. Good afternoon. How are you doing?
I'm good, sir.
All right. I'm not sure how many more persons are gonna join. As I literally just sent out the link. I just posted it in my classroom. I just sent you it as well. So maybe 2 or 3 more persons will eventually join.
Okay, sir.
All right. So today's series, we're gonna go through the 2023 January paper. So this was a paper that persons that did math, persons that did math in January, they would have done this paper. Because there's 2 times of the year you can do CXC. January and of course the May exam. By the way, I have your timetable. So when you come into the marathon this Saturday, I'll give you a timetable, all right?
Yes, sir.
And I want you to, of course, cherish it. Cherish it. It's your first time doing CXC. Cherish your timetable. In the meantime, we're going to start. As I say, maybe 2 or 3 more persons are going to join, and we're going to have a lot of fun. So let's just start. So, we're going to do a full paper today, and it's always fun to do a full paper. All right. So when you go in the exam, you're going to see this. The front of the page is going to look like this. And the key thing is, of course, you're going to have to answer all the questions. You're going to have to answer what?
All the questions.
All the questions. That's the key thing. All right. So go ahead. So, of course, the formula sheet, if you don't remember a particular formula, you can always visit it to refresh your memory. All right. Now, series, this is question 1. I don't want you to waste any time when you're doing question 1. When you're doing question 1, you went downtown during the Christmas holiday to buy an expensive calculator. So put an expensive calculator to the work. I don't want you actually work out wholly for something. Just put it in the calculator. All right. But if you just put it in the calculator, you get 1 mark. Notice how much marks is for this question.
2.
2. So to get the 2 marks, what you're going to show them is put in square root 108 in the calculator first. Square root 108. That part is, of course, a 6 root 3 or a 10.3923. So you put here 10.23923 divided by, add the denominator, put that in the calculator next. 19.72 plus 5.296, which is your 25.016. Now, after you do that series, that give you 1 mark. This give you how much mark?
1 mark.
This give you 1 mark. To get the next 1 mark now you're going to put the rest in a calculator. So now you're going to put in the 10.23923 over the 25.016. Plug it in, and the final answer is 0.4093. But they said they want it to 1 significant figure series, just one. The 0 here is not significant, so it's just 0.4 to 1 significant figure, right?
Yes, sir.
As I said, series, if you did just go and put it in the calculator, square root 108 over 19.72 plus 5.296. If you had put this in the calculator 1 time and you get a 0.4, you'd only get 1 mark. You have to show them the 2-step. All right?
Yes, sir.
Cool. All right. All right. Now, part 2 here, Again, notice you see what? 3 mark. So again, series, we want to save time. We're not going to work out anything. We're not finding any LCM. We're not doing any of that. We're just going to use our
Calculator.
calculator. Using the calculator series, we have 3 and 3 over 8 divide by. Now you need to work out this part in the calculator because you always do what first? Brackets, don't?
Yes, sir.
We always do bracket first. So we put in the bracket 5 over 12 plus or 1 over 3. Put that in the bracket and we'll get 3/4. That gave us, how much marks that gave us?
1.
Get 1 mark. Now we need to do the division. No, serious, so let's do the division. So now we just put in, you know how to get this type of fraction, right? You press shift, then the fraction button. That give you the mixed fraction, right?
Okay, yes, sir.
So put in your calculator and tell me how much you get. You have your calculator with you?
Yes, sir, I do.
Put it in and tell me how much you get.
9 over 2.
9 over 2. Yep. No, that give you how much mark?
1.
Another 1 mark. And the final mark is to put it as a mixed number, which we know that would be 4 and 1 over 2, right?
Yes, sir.
Easy peasy, nice. Don't waste time with them. These questions, we don't waste time on. We just plug them in the calculator. Yeah, easy. Imagine, this is how CXC gonna feel, you know? Easy, don't it?
Yes, sir.
First, read this question for me.
Due to the COVID-19 pandemic, seats in a hall was reduced from 159 to 93. Calculate the percentage decrease in the number of seats available.
Good. So, percentage decrease. First thing we need to find out is what is the decrease. So the
So we
decrease
subtract
is, so we subtract. Very good, we subtract. 125 minus 93 is what?
32.
32. Now we need to find the percentage decrease. So the percentage decrease is equal to the decrease amount over the initial value times 100, right?
Yes, sir.
So 32 over what was the initial value?
125.
Very good, 125 over 100. Then, of course, series, in this day and age, we put it in our calculator. We don't waste any time. We just put it straight into the calculator. Wham, and that's our answer, 25.6%. Cool?
Yes, sir.
Done. You get 1 mark for, of course, working out the decrease, 1 mark, your percentage, and you move on. This part now, can you read it for me, please?
Micah invests.
That's Micah. Is that really Micah or Micah? I don't know. I'm asking.
Micah
All right, Micah, go ahead.
Micah invests a certain amount of money in a bank that pays compound interest at a rate of 2.5% per annum. At the end of 2 years, the value of her investment is $7,564.50. Calculate the amount Micah invests.
Let's calculate the amount Micah invests. First thing, they said at the end of 2 years. So this 2 is what?
This too is the time.
Time. Very good. And notice what they're using for time. Number of years is n. So this is the time. All right. So the n right there is time. I usually use t, but they're using n. That's fine. Now, a is what? The total amount after in years. What
In
was the total amount?
$7,564.50.
Very good. So we can write that A is 7,600. Oh, 7,564 and 50 cents equal. Did they give us the initial value?
Um, no.
No. So P is what we're trying to find. Calculate the amount Micah invests. Invest was the original value. How much did we invest? So that's what we're trying to find. P in bracket, 1 plus R. What was the interest rate?
The interest rate 2.5%.
Very good. So we put 2.5 over 100. And N we said was 2 years. So we put N as 2. All right. So this was N. This was A. And the 2.5 was, of course, R. And they will plug it in the formula they give us. So now you, again, series, this day and age, we don't waste no time. So this part of the equation, put in the calculator, the part that says 1 plus fraction 2.5 over 100, close the bracket, then we square it. We'll work out that part, we get this amount, don't? And as a decimal, it's
Yes.
this. It is 1.050625 multiplied by P, and it's equal to the 7,564.50. How we gonna find P when we get to that stage?
We divide
Very good.
4,000.
We divide. Very good. So when we divide now, we'll just put that in the calculator. Put in years and tell me what you get.
7,200.
Very good. So that was the initial value. So P is just, don't forget your dollar sign, $7,200. And question one is finished just like that. Wasn't bad, right?
No, sir.
And of course, don't worry, I'm going to send you this annotation. We'll finish I'm going to send you the fresh copy as well as a copy with the answers, all right?
Yes, sir.
A nice full paper, and this was January. Cannot get any easier. This year, laws of indices, question number 2. Now, remember, x cubed square mean we're multiplying x cubed times x cubed. That's what square mean, don't?
Yes, sir.
And when the bases are the same, we add the powers, right?
Yes,
We're
sir.
done. Or you could have used a rule that tell us that we just multiply the 3 times the 2. No problem. So that was quite easy. Now we're dividing and they're the same base. So what do we do again?
We subtract.
We subtract the powers. Very good. So in this case, we have y to the 8 minus, but we have negative 5. When we subtract a negative, it becomes
Positive.
positive. So 8 plus 5 is just 13. They call it the lucky number. Lucky number 13. Is it lucky or they say it's the bad lucky number?
Bad luck.
Bad luck. Why they say 13 is bad luck? What's the reason behind that?
Not sure, but I believe it.
That's crazy. All right. So this one now, factorize. First thing, we look at what they have in common. These two have what they have in common. Y.
Y.
So we take out the y. Of course, then we divide x, y by the y. And we divide y square by the y. And so we have y in bracket x minus y, right?
Uh, Confused.
Oh, remember what with factorization, what's the first step? we identify the highest common factor. The highest common factor would be what?
Y.
Y. So when we take out the y, right, we have to now divide both terms inside the bracket by the highest common factor, right?
Yes, sir.
Because what we're doing is the opposite of expanding the bracket. Notice your answer. If you were to expand back y in bracket x minus y, what would you do? Multiply y times x to get xy. Then you
Y.
multiply y times y to get back the y
Y
squared.
squared.
So it must correct, don't?
Yes, sir.
You just have to remember, factorizing is opposite of um, just the opposite of expanding brackets. So that's all. Now the second one here, this is usually the one that persons tend to forget. This is what we call difference of two squared. So I have to remember a squared minus b squared. The formula is a minus b times a plus b, right?
Yes, sir.
So x squared minus y squared gonna become, or x is a, so it becomes what?
Would you multiply what's outside by what's inside?
No, so only thing now, the x is where the a is where the x is, or the x is where the a is, and the b gonna be where the y is. To factorize it using this formula, what we call difference of two square. So for example, 9 square minus 4 square is
Oh,
9
so our
minus
answer
4.
is x minus y times x plus y.
Exactly, that's what I'm waiting for. Easy. Move on. Simple. Too easy, right?
Yes, sir.
Now, series, the next part now, they say simplify this. Now, at first it looks crazy, but they said keyword ends. Above, we realize xy minus y squared. We said that was y in bracket x minus y, right?
Yes, sir.
And then we said x squared minus y squared is x minus y times x plus y. Now, series we learned from many years ago. Well, not maybe so much many years ago, but maybe about, grade 4 or 5. We learned that we can cancel when we have the same term in the numerator and the denominator, don't?
Yes, sir. So
So we
x and y.
cancel. X minus y cancel each other.
So
And
y
so
over x plus y.
easy. Y over x plus y, and we finish. That's our answer. That's a simplified answer. Very easy, right? Very easy for a CXC paper, don't?
Yes, sir.
Yeah, this is January. Now, let's see what they try to do to let the question get nicer. So here they tell us the diagram shows two rectangles, M and N, with their dimensions expressed in terms of X. And they say give the difference between the areas of the given the difference between the two rectangles is 64, show that x squared minus 2x minus 35 is equal to 0. Now, to do this series, what do we know? First thing, we need to do, they said the difference between the two rectangle areas is 64. So that means that the area of M minus the area of N equal 64. That's the difference, right? So the area of rectangle M minus the area of rectangle N equals 64. Difference mean we subtract, right?
Yes, sir.
So let's go ahead. Let's go ahead now, find the difference. So the area of M would be computed by we multiply length times width to find area. So we multiply 3x plus 4 times x minus 3. Then we subtract the area of N multiplied x minus 3 times x plus 2, and that should be equal to 64, right?
Yes, sir.
So good evening. Good evening. That's for Desna. Good evening, Tamika. Good evening, Malik. Now, straight away, what we notice here, I notice something. On the left side, right, I notice I have a x minus 3, right?
Yes,
And on the right side, I notice I have a x minus 3. So on the left of the minus sign and the right of the minus sign, I notice we have a x minus 3. So from factorization, we know we can take out what is in common, right?
yes,
We can do it that way first, of course. Or if you don't want to take out, you can just multiply straight away. So it depends. Let's just say most persons want to multiply, right? So that's fine. Let's just multiply. So of course, we multiply 3x times x. So remember, we're going to multiply 3x times the x minus 3. Then the positive 4 times the x minus 3. Then over here we have minus. And I put another bracket because we have to minus everything that we multiply first. So we have to multiply the x times the x plus 2. Then the minus 3 times the x plus 2. And after we do all of that, then we subtract it. And the result should be 64, right?
yes, sir.
So going ahead, we'll multiply 3x times x to give us 3x squared. We multiply 3x times 3 to get minus 9x. We multiply 4 times x to get 4x. We multiply 4 times minus 3 to get negative 12. Then we subtract. In here now, x times x give us x squared. X times 2 give us 2x. Negative 3 times x give us minus 3x. And negative 3 times 2 give us minus 6. At this point now, only thing we really need to do now is, of course, just go ahead and simplify. So now let's go ahead and simplify. So 3x squared, put that back. Now minus 9x plus 4x, those are like terms, so we can always simplify that, right?
Yes, sir.
So minus 9x plus 4x is what? Minus 9x plus 4x? Negative 5x, right?
Yes,
Then we have minus in bracket x squared. Now 2x minus 3x is negative x minus 6. Now here's where it gets tricky. Well, it doesn't get tricky, but oftentimes a lot of persons tend to forget that when you expand the negative applies to all the term inside the bracket. So it's 3x squared minus 5x minus 12. Key thing now, negative x squared, then negative times negative, let it become plus x, then negative times negative, let it become plus 6 equal 64. Cool? Now we group like terms again. 3x squared minus x squared, that become 2x squared. Then we go minus 5x plus x is minus 4x. Then we go minus 12 plus 6, that become negative 6 equals 64. Then we notice everything have the number 2 in common, don't it?
yes, sir.
When they have 2 in common, you can always divide through by the common factor. So if we divide through by 2, it becomes x squared minus 2x minus 3 equal, I think this would be 30. 32. 64 divided by 2 is 32. Then, of course, we need everything to be to one side. So bring over the 32 over to the left. So x squared minus 2x minus 3 minus 32 equals 0, which is x squared minus 2x minus 35 equals 0. Done. So that's what the question had asked. The question had asked for us to show that it was going to lead to this quadratic. At first, it seemed like an easy question. Many persons probably write this down first. Area of M minus area of N is 64. But then when they see the quadratic, or when they see they need to expand and get the quadratic. They just can't bother. They just say, Choya, too much work. But do it, get the 4 marks. It worked 4, right? Because it was a lot of work, right?
Yes.
All right. Moving along, but let me plug in this computer. Hey. All right. All right, so this question now, number 3. Number 3 is usually going to be geometric transformation. Now, this topic, for the most part, oftentimes when we go into exam, most students don't get to learn geometric transformation. The reason why the syllabus is so long, that the truth is most teachers don't get to cover geometric transformation. And I myself might be guilty of that sometimes. That's how long the syllabus is, but no problem. So it says the following diagram shows 3 quadrilaterals, PQR on a square grid. Q and R are the images of P. That means images mean P is the original thing. The Q and R, these are produced.
So that means enlarge, right? It's like enlargement.
Yes. So we notice that Q would be the enlargement, yes. And R would be what? Rotation. We notice that. But yes, as we're saying, P is just the original thing though. That's the key thing when they give all of this wording. So the wording might seem confusing, but that's all they're saying. Cool?
Yes, sir.
Yeah. So now let's hear what they say. What they say now is that on the grid, draw the image of the quadrilateral P after translating by the vector 10 minus 4. Always remember, when we're doing coordinate geometry, right? Points is given x, y. This vector, this is a vector, right? Where the x value is 10, y value is negative 4. So anytime it's a positive x value, all that means is that we're going to the right. It's just like graph, you know. So we're going to move P to the right by 10. This means we move 10 units to the right. X values, the first value that you get in the translation vector is either to the left or the right. If it's negative, to the left. If it's positive, to the right. When the y value now below is positive, you go up. When the y value is negative, naturally we go down. This means 4 units down. And this is we're moving P. So let's go ahead and do that. So moving P, 10 units to the left first, then 4 units down. So first, mark each point. So let's start with this point I put in red. 10 units to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 is right here. Now the one, let me put it at black at the top here. This one at the top vertex of P go to the left. It would be all the way over here. Then now this one I'm gonna put in pink. If we move it over 10 units to the right, it should be here. Then finally, the one down here, let me put like a cross. That one down there, moving it 10 units, it's gonna be somewhere here. Then of course, you connect it to get back your quadrilateral. Use your ruler, just look like how I am going to use my ruler. Doom, use a ruler, make it straight. Then of course you label it. And the labeling they say we should give it is P prime. This give you 1 mark, 1 easy mark. You put P prime. P prime, that's it. Oh, my apologies. Did I go down or did I just go across? I didn't go down yet.
No, it didn't go down.
Oh, thank you. Thank you. So look at that. So I didn't go down yet. These points now I need to move it 4 units down, all right? Don't know why I didn't remember to go 4 units down. So for the black one, 1, 2, 3, 4 here. For the red one, 4 units down, 1, 2, 3, 4 right here. For the pink, right here. Then finally for the little cross, 1, 2, 3, 4 units down right here. So don't give it away. Don't go down and then forget to go up, or don't go down and forget to go across. All right. Always remember you have to go across and up or down. All right. So don't forget. Don't do one and forget the other. All right. Then we can of course label it up. And remember, when you're doing graph, use pencil just in case you make an error like that. Like you just forget and you say, oh, wait, make a mistake. Use a pencil so we can always correct it like that. No issue. Small stuff. Next one, reflection. A nice one. And they said to reflect it in the line y equals 0. Now, the line y equals 0 is oftentimes confused. Like that. We don't remember which one is the line y equals 0. Notice, if I were to show you this line, this horizontal line right here, this is a line y equal 2, because everywhere on this line, the y value is what? 2. Isn't that so?
Yes.
So if we move this line go down, we'll move it go down to the x-axis, we'll notice the x-axis then, the x-axis, that is actually the line y equal to 0. The x-axis right here, let me show you. If we look at this point right here, this is the point what? -6, 0. This is the point, -4, 0. Notice along this line, the y values is always 0. And so we call that the line y equals 0. So the x-axis, just to write it down, key information, the x-axis, this is the line y equal to 0. Key information, the x-axis is the line y equals 0, and the y-axis is the line x equal to 0. Key information. But we only focus on, right now, the line y equals 0, which is the x-axis. And what they say we need to do, reflect it in the line. They say we need to reflect quadrilateral P in the line y equals 0. So the first thing, draw the line y equals 0, brighten it, right? So you use a pencil, highlight it, I'll change the color. Let me use blue. So I'm using blue here. This is the line y equals 0. All right. And then when you highlight it with your pencil in the exam, tell them see it here just to show them, say, understand what you're doing. That's the line y equals 0. Second thing now is we're going to do the reflection. Reflection, the orientation, it's not going to change. It's not going to turn left or right like this one are here. That's rotation. The orientation not going to change like that. What only thing that will change is the distance from the mirror line. So you notice this, the closer you stand up to a mirror, the closer you see an image in the mirror. But if you stand further away from your mirror, then the image would also be further away, don't it? We agree with that?
Yes.
Yes. So the point right here, this point right here, we notice it is 1, 2, 3, 4 units from the mirror line. So therefore, the image will also be 4 units from the mirror line. I'm going to zoom out so see it a little bit better. If I zoom out, this point right here, with the cross, 4 units from the mirror line. So 4 units from the mirror line. On the other side, 1, 2, 3, 4, right here. Then now, the one with the pink, we need to be, how many distance from the mirror line this is? 1, 2, 3, 4, 5, 6 from the mirror line. So we'll go down 1, 2, 3, 4, 5, 6. So here is the pink. Next now, let's look at the red circle. This is 6 from the mirror line as well. So we'll put it here. And then finally the black. That looks like 1, 2, 3, 4, 5, 6, 7 from the mirror line. So we'll go down 7, and it would be right here. Then, of course, them set the label it P prime prime. Always remember the apostrophe mean prime. It's not English. Don't say P apostrophe apostrophe. Don't say P apostrophe apostrophe. P prime prime. This is mathematics. Prime prime. And then, of course, we put our label P prime prime. Cool. That's our reflection. Now, after we reflect it, we get 3 marks so far. That's crazy. Just 3. After all of them points there, no problem. Now it says, describe fully the single transformation that maps P onto Q. Now to map P to Q, we notice that P and Q, they're in the same orientation. The only difference is Q is bigger than P. So it is enlargement. It is what? Enlargement. Now the key thing is, you can't, if you tell them it's enlargement, you get 1 mark. This is how you get your 3 marks. You have to tell them what type of transformation it is, either reflection, rotation, transformation, or translation. You get 1 mark for telling them which transformation it is. Then you get the next mark for telling them the center. You have to tell them the center of the transformation. And then finally, if it's an enlargement, you're going to have to tell them the scale factor. Each one give you a mark. We already know P to Q is enlargement, but let's find the center of enlargement. To get the center of enlargement, what you're going to do is draw a straight line passing through each corresponding point. So I notice if I draw these points right here correspond to each other. So if I draw the straight line passing through those points, that's it right there. Now, corresponding point here for the pink one would be this one here. I'm gonna use I'll use the same blue line. So I need a line passing through this point and this point. All right, that would be the line. Then I need a line passing through the next corresponding point, the star one, that corresponds to the one down the bottom here. I draw a line. Now, where all the lines meet, that is the center of the enlargement. So the center of the enlargement, we realize is this point right here. So the center of enlargement is the x value is -10 and the y value is, that is positive 7. That's positive 7. I know I missed out this point, but you can go ahead and continue and get the same. You're gonna all intersect at that point. Next thing we need is the scale factor. We notice this right here. Let's just, that's not really 1 unit, but we'll get the idea what I'm saying. We'll see 1 line there, but this would be 1, 2, 3 lines. So clearly, center of, and see there, that's 3. All right. And then now, down here, notice 1, 2, so guarantee at the bottom gonna be 6. 1, 2, 3, 4, 5, 6. See there? 6 divided by 2 is still 3. So in that case, of course, the scale factor is positive 3. So now we're going to tell them all of that. So we can tell them P is mapped to Q by, P is mapped to Q by an enlargement with a scale factor of 3 and a center of enlargement, and the center of enlargement was -10, positive 7. And that's it. P is mapped to Q by an enlargement with a scale factor of 3 and a center of enlargement, -10, 7. Now, they said describe fully. That's why we had to tell them all of that for the 3 marks. A lot of chatting, that is okay. It's a lot of chatting, that's okay. Next one now, describe now the single transformation that maps Q to R. So now we're dealing Q to R, oh, P onto R. So now we're looking at P onto R right here. We know it is rotation. We know it is rotation. Now, there are only 3 types of rotation that's going to come on the exam. It's always what? Either 90 degrees rotation clockwise, 90-degree anti-clockwise, or 180-degree rotation. It's always one of the 3. Either 90-degree clockwise, 90-degree anti-clockwise, or it's 180-degree rotation. One of those 3 always come. Now, what I always recommend remembering is what we call the rotation matrix to verify which one it is. I like to do it by the verification method. The first thing is you look at this point right here, the black point at the top. That point is the x value is -7 and the y value is +7. I don't know why it's not writing. This value up here is -7 and the y value is +7. Now, the corresponding rotated point would be right here. And this point is what? We realize that this point is negative, that is -9, and the y value is -1. All right, cool. So it went from -7 to 7, then -9, -1. All right. Now, clearly then, the rotation is not from the center. When it is from the center, you would just flip it and change the signs. It's clearly not from the center. So when it's from the center, we know the result would just be, we rotate the y and the x. So where the y is, the x become. So it would just be 7 there, -7, and then we negate it. I'll get with -7, -7. But we notice we don't get that. We don't get nothing involving 7, 7. So clearly it's not from the center. All right, so writing down the points, then where it go from first, they will go and determine our center of rotation. So it went from -7, 7 to -9, -1. Then the next point we can observe, really and truly 2 points is sufficient to observe. Then the others will follow. This point right here, I put at the bottom in red. The x value is -7 and the y value is +4. And then down here, so it go from -7, +4 to, then of course we notice it went to down at the bottom here is -6, just to zoom, -6, and the y value, of course, -1. All right, so that is -6, -1. All right, and if you want to just throw in any of the other points, all right, because I don't know which 2 you would have selected. Maybe somebody else would have selected the other vertex or other vertex point. Let's say you had selected this one. That's fine. You just have to select the corresponding one to it, which is this one. All right, so if you had selected this one, no problem. All right, and this would have been -6, y value +6. So -6, +6 too. This one here, right here would be -8, and the y value is 0. By the way, which direction is clockwise? All right, so when something turned this way, it is what? Going this way, this way. Which one is clockwise? Arrow going this way and this way. Which one is clockwise?
First one.
The first one is clockwise and the next one is anti-clockwise. Very good. So the first one is clockwise and then this one is anti-clockwise. Very good. Now, here's how we deal with this now when it's not from the origin. To deal with when it's not from the origin now, right, we need to picture as if we're rotating it. Let's picture as if we're rotating it from the origin first, and then we do our little addition in order to get back the resulting point. So, all right, so look what I'm saying. So the minus 7 here, right? If we were actually rotating this from the center, right? And let's assume this is anti-clockwise, right? Because look, it go this way, right? We rotate it that way. If we really check it out, it's really anti-clockwise, right? But see there, anti-clockwise, right? So look what we're saying now. Need more. Would love to have some space here, but no problem. So let me just take it to the blank screen. So right here, when we have minus 7, 7, right? The anti-clockwise matrix, always remember this. Let me write it at the top because sometimes I always remember the matrix method. The clockwise matrix is 0, 1, minus 1, 0. This is clockwise for 90 degrees, of course. And the anti is the one that goes 0, minus 1, 1, 0. So if we look at right here now, right, let's look at the anti-clockwise. If we have the point minus 7, 7 right here, all right, I put it in vector form, of course, and we'll multiply it by 0, minus 1, 1, 0. We have to remember some matrix. Notice when you multiply them, I just doing the first one so we catch the idea. We multiply row by column. So 0
Right.
times minus 7, 0 times minus
0.
7, 0. Then, of course, we add our negative 1 times our 7. Then the next one will go the row at the bottom times the column. 1 times negative 7 plus 0 times 7. So, of course, this would result in negative 7, negative 7.
You say just one question, one question. Sure. Too much
Yeah,
more.
repeat?
One
Yeah,
question.
yeah, for once.
One
No, the
question.
thing is, no, this question, notice how long we spend on it. That's because this
Right.
concept, at the start, remember what I said. At the start of this question, I said, oftentimes, when you're doing it in an exam, you'd have done in 5 minutes. But what did I say? At the start of the test, oftentimes this topic is, teachers don't get to teach this topic, all right? They just run out of time because for the entire year, you're doing many different topics in maths and we don't get to this topic. So of course, now when you're doing past papers and you book up on this topic, we'll spend a little time explaining it. But once you get the gist in an exam, you won't take more than 5 minutes, I promise you. All right. It's just the explanation will take a little while. All right. So that's what it would be. All right. But this wasn't the resulting point we get. All right. This wasn't the resulting point. What was the resulting point after we did that? Remember our resulting point right here was -9, -1. So something happened. So it ended up being -9, -1. All right. So notice for it to be -9 here, really add a -2. And for it to be -7 here, really add from -7. Oh, this was what? I'll go back. Oh, this was -1. So for it to go from -7 to -1, what do we add so it become -1? We add +6, right? -7 plus +6 give us -1, right? Agreed? Do you agree with this?
Yes.
Yes, sir.
Yes, so our center then is actually -2, 6. All right, so now it is a 90-degree anti-clockwise rotation with center -2, +6. That's all. All right, so now we're just going to state that for them. That's all. We just use any one of the point, and that's it. So now we can tell them it is a 90-degree anti. By the way, just to say 90-degree, 1 mark, that giving them the degree of rotation. They would tell them anti-clockwise. That gives us another mark, anti-clockwise rotation. Then, of course, we tell them about, and the center of rotation was -2, +6. 90-degree anti-clockwise rotation, about -2, +6. As I say in an exam, it won't take more than 5 minutes to do this question. It's just that we expound on it. Geometric transformation. So usually question 3 is fully geometric transformation. Then number 4 is going to be coordinate geometry. An easy topic. Coordinate geometry is number 4. So x-intercept. There's a term that we need to remember whenever you see a question say x-intercept. X-intercept, just remember, is what we call root. Another word you'll see for it is root, and the root occur when y equals 0. So they say L and M are drawn on the grid. Write down the x-intercept of the line L. This is the line L. Say L here, this is L. The x-intercept given, see it here? Write down the coordinates though. So the coordinates is the x value is 6 and the y value is 0. Then now for M, they say write down the y-intercept. Y-intercept that occur when x is 0 now. Y-intercept occur when the x is 0. And this is for line M. So for line M, this is it now. The x value is 0 and the y value is -2. So the coordinates 0, -2. Cannot get any easier than that. Now, they tell us this information. It says the equation of L is x plus 2y minus 6. It says find the value of k given that the point is on the line. Now, when we see a question like this, always remember, if the point is on the line, then that means the point will satisfy the equation of the line. So what they're telling you right here is the x value is 9 and the y value is k. Find k. So plug it in the equation. 9 plus 2 times k minus 6 equals 0. 9 minus 6 is +3. So 3 plus 2k equals 0. 2k equal -3. K equal -3/2. In other words, k is -1.5. Cannot be any easier than that, right? Right? We're good? No,
Yeah.
you can always check it now. So, you check your answer. Remember, we said that the x value is 9. The y value should be -1.5. Don't know why the point keep disappearing. So let's check it on the graph. So remember, the x value is 9, and now the y value should be -1.5. And this was for line L. If you go back to line L, when the x value is 9 right here, the y value should be -1.5. But look at that. See it here? This is the -1.5. Isn't that so? Isn't that -1.5?
Yes,
Yes.
sir. It is.
And we know that we're correct then. That's what I love with. When you get graph, use a graph and check back your answer. Now, hear what they say. They say find the equation of line M in the form y equal mx plus c. But they say line M. The line M, this is line M. To find the equation of a line, you need to know two things. You need to know gradient and the y-intercept. We already have the y-intercept, the 0 minus 2. So for M, we just need to find the gradient. We'll find the gradient, just to highlight M again. You use any 2 points on the line, any 2 points. The 2 points I want to use, I like to use points that are vivid. So I'm going to use this point, that is 3, the x value. So 3 and 4, and I'm going to use this point here. That is the point 1, x is 1, y value is 0. So using those 2 points, right? So in this case, the gradient is equal to, remember gradient is y2 minus y1 over x2 minus x1. So y2, call it 4, 4 minus 0 over x2, 3 minus 1. So that is 4 over 2, which is positive 2. And we already know the y-intercept was negative 2. So in that case now, we can, and remember the y-intercept is negative 2. So we already know c is negative 2 from part A2. So therefore, the equation of the line is y equal the gradient, m, which is 2, x plus c, but c is negative 2. We're done. So y is 2x minus 2. Easy. Now they say, show by calculation that the line L and M are perpendicular. So show by calculation that the line L and M are perpendicular. So we have to remember, if two lines are perpendicular, then the product of their gradient is negative 1. So remember, if L and M are perpendicular, this symbol means perpendicular. Remember, perpendicular means they meet at 90 degrees. So if L and M are perpendicular, then the gradient of line L times the gradient of line M should equal negative 1. Now, we already know the gradient of line M. The gradient of line M we said was 2. Now we can find the gradient of line L. All right? So find the gradient of line L now. So using two distinct points, I'll use this point, which is 0, 3, and this point, which is 6, 0. So the gradient of L, if we look at it, it's y2. I'm calling y2 the 3 here. 3 minus 0 over x2, 0 minus 6. 3 minus 0 is 3. 0 minus 6 is negative 6. And 3 over negative 6 is minus a half. So now we can tell them the gradient of L times the gradient of M is equal to negative a half times the gradient of M was 2. And voila, we get negative 1. Since we get negative 1, we can say, therefore, the two lines are, and if you want to look really intelligent, write this word, orthogonal. It also means perpendicular. All right, this is a term for persons who plan to the additional mathematics. You'll see this term in AdMaths, but orthogonal means perpendicular. You can Google it. You know, orthogonal means meet at 90 degrees. It always looks nice to just put something different on your paper, don't it? That
Yes,
looks,
sir.
yeah, so we can say orthogonal. It means perpendicular. Now, part E here now, it says line L and line M represent the graph of a pair of simultaneous equations. So we already know the two equations, right? They give you it already. The first one was the x plus 2y minus 6 equals 0. And the next equation we had was y equal the 2x minus 2. Now, they're not asking you to solve those simultaneously. Now, what they're saying is write down the solution to the pair of simultaneous equation. What they're asking you for is, remember, when you solve simultaneous equation, you are finding the point of intersection between two lines. Let me say that again. When you solve simultaneous equation, you are finding the point of intersection between the lines. So go to your graph and look at the point of intersection. The point of intersection is 2, 2. So that's all you'll write. So write down the solution. The solution is, put 2, 2 now. So put 2, comma 2. Or some people like to write their solution like this, x equal 2 and y equal 2. 1 mark. Now, I guarantee you somebody is going to do simultaneous equation. Somebody is going to be say, 1 mark to all of this. Somebody is going to put the y here and say x plus 2 times substitute. And we have 2x minus 2 minus 6 equals 0. And we're solving x plus 4x minus 4 minus 6 equals 0. X plus 4x is 5x. Minus 4 minus 6 is minus 10 equals 0. Divide by 5. And so clearly x is 2. When they get x is 2, they plug 2 in the equation and say y is now 2 times 2 minus 2, which is 4 minus 2, which is 2. By the time you do all of that for solving simultaneous equation, you're tired, you're boss. Read the question. Don't overwork yourself. Follow what they say. Write down mean you don't need to solve. But if you solve it, you can solve it and just verify that you get the same answer, right? Oh, good with this question. Easy, don't? January paper, nice so far. Not too bad. Now, cumulative frequency, one of the nicest topics. All right. It says the cumulative frequency curve below. Oh, by the way, question 5 is always statistics. So question 5, always statistics. Number 4, always coordinate geometry. Number 3, geometric transformation. Number 2, gonna be a mixture of factorization, quadratics, area. That's question 2. Question 1, going to be now fractions, decimals, significant figures, standard form, higher purchase, profit and loss, consumer arithmetic, basically. Those stuff come in number 1, ratios. So now they give us this cumulative frequency graph. We're not gonna, well, we don't need to read it because they tell us everything is labeled on it. So of course it shows about the time taken by 200 students to solve a problem. So it must be some hard problem for it to be taking 40 and 30 minutes for us to solve. Nothing is wrong with that. It says using the cumulative frequency, find an estimate for the number of students who took more than 50 minutes to solve the problem. All right. The number of students that took more than 50 minutes. So first thing you're going to do is draw like a line from 50 minutes going up. We draw a line from 50 minutes going up, then we go across. All right, first thing you have to look at what the scale is saying. Notice it goes from 0 to 20 in 1 centimeter, but this has 5 divisions. So it's really 16, 12, 8, 4. So each one is going up by 4. So if we go across right here, this number would apparently be 196. Do you agree with that? We agree?
Yes, sir.
Yes. So the division is going up by increments of 4. So if this is 196, what did they say? They say how many students took more? More would mean we look above. Look above it. So from more would be above it now. So 4 students to go from 196 to 200, the difference is 4. So 4 students took more than 50 minutes. So we can tell them 4 students. Now they ask us for the median time. To find the median, you divide the cumulative frequency by 2 first. So 200 divided by 2 is 100. You go down to 100, they're going to draw a line, come over, and then the corresponding x value, that is going to be your median. So we scroll all the way down to the bottom, down here, and my estimation, let's see, this look like 31, 32, 33, maybe 33.5. If you put 33 or 34 based on your graph, they'll give it to you. All right. But my estimation from my graph is giving me 33.5. We agree with 33.5?
Yes, sir.
So 33.5 minutes. So that's the median time to solve the problem. Now it says, of course, determine the probability that a student chosen at random took at most 28 minutes. At most mean, if I say to you, students, you have at most 28 minutes to solve the problem, that means 28 or less. So you can take 10, you can take 5, but once 28 minutes finish, I'm going to say, students, hand up your paper. Your time is done. So now that's all we're doing. It says at most 28. So we're going to go and draw our line at 28. So we'll take out back our ruler. I'll go to 28. This is 25, 26, 27, 28. We draw a line at 28. And then we go across. And going across, that is 64. So this right here is 64. So to take at most 28 minutes is 64 out of the total number of students. Remember, that's probability. So 64 out of 200. Now you can give your answer like this, or remember that you can always give your answer as a decimal. So you can put 64 divided by 200, which is 0.32. Or you can give your answer as a percentage, which is 32%. So anyway you feel like giving your answer is fine. So you can write that, or you can say 32%. Really up to you. Now it says complete the table. It says using the cumulative frequency curve, complete the table. So of course we need, notice midpoint 5.5, they get the frequency to be 12. So you're gonna look 5.5, frequency was 12. You can verify, let's see, 5.5, 5 is here. Whoa, 5 here, and this is 12. That's what they're saying at 5.5. Somewhere here, they're saying this frequency was 12. All right. And then the next one they set in the table was 25.5. The frequency was 42. So just verify with them. They say at 25.5, somewhere here, they're saying the frequency was 42. 25.5, they get 42, yes. 25.5 here. That doesn't look like 42 to me. Well, yes, it would be 42. It would be 42. Let's look at y. All right. Now, y is, remember, we have to subtract out the frequencies from previously as well, because all of this must add up to be what again? 200, right? We agree?
Yes.
The frequency must add up to be this amount. And remember, so right here, the graph we have is giving us the cumulative frequency. So we have 12, so we're going to get a number, and whatever number, we add 42 to it, whatever number, 42 added to it again, then 84 added to it again. So we know automatically right here, right, when we add the 4, that's how we get the 200. This is how we get the 200. So subtract 4 from this, right? We know the cumulative frequency right here would be 196, right? And if we subtract out 84, look how we're doing this without even doing the cumulative frequency. Look how we're just using our head on them. 196 minus 84, that should give us 112. If we subtract out now 42, if we subtract out 42, that should give us 70, right? And then that would be the only one now that we really have to necessarily figure out, right? That's the only one we necessarily have to figure out, don't? This one right here. But of course, let's go ahead now and we use our cumulative frequency. We'll go 15.5 for x. I won't get 0.5 perfectly accurate because 0.5 is like in the middle between 15 and 16. So I won't get it perfect, but bear with me, I'm using pink for this one. So 15.5, my estimation is here. It's not going to be perfect. And my estimation look roughly like 24. Again, that's my estimation. My estimation is 24. Now remember, when we get 24, that means the cumulative frequency up to here is 24, right? The cumulative frequency up to there is 24. So if we go 24 minus 12, then this frequency should be 12, right? Notice when you add the 12 and 12, 24, we add now the 24 and add the 24 and 42. This should be how much? 24 and 42 should be what? 24 and 42 should be what?
66, sir.
66. So that means if you actually check it out, when you put 25.5, you should get the 66. So if you go 25.5 and go up, you should get your 66. So 25.5 going up. This is 25, 25.5. This is right here. I am getting my 25.5 giving me 44, 48, 52. That's 52. And this is 66. Let's go back. Look at 15.5. All right, because they have 60, they have 42 here, and our addition is giving us 66. But our graph is telling me, our graph is clearly telling us 52. So let's double check that again. All right, this is 5.5. 5.5 here is 5.5. We'll go up. This is 4. And this is 4. Wait, 5.5 is how much? This is how much? 5.5. What's the y value that correspond to it? This is 4. This would be something like 7 or 6, don't? You don't reach the second line yet. So this is 7 or 6, right? You agree? That this is for 5.5. This is 7 or 6, don't?
6, sir.
All right. Let's just stick a pin. Because that would be 6, but they're not using 6. I guess they're not using the midpoint. All right, so they're not using the midpoint to estimate these numbers here. It look like they're using the end values. All right, so good observation for us to notice. For them to get the 12, it clearly couldn't be the midpoint value they're using. So now we have to look at 10. All right, so no problem. If we look at 10, there we go. That's how they get the 12. So see there, good thing we're paying attention is that the 10 they actually use to get the 12. That's why they give you a point, and they give you a point so you can then analyze. All right. So is that the 10 they use to get the 12? Okay, now the question is going to make sense. So is that the 10 they use to get the 12? So that means we're going to have to look at the 20 then to get our answer. Now it makes sense because a while ago it was never going to add up to be the 200. All right, it was never going to add up to be the 200. Cumulative frequency, this is 12.
I think the second one would be 29 or something like that.
Yeah, so we'll go at 20 now and go up. So at 20, go down, go across. How much you get? 29? 4, 24, 28, 32. More than 29, man. 32. Maybe more like one less than 36. Maybe we can say 35, right? Can go with 35? 35? We okay with 35?
Sir, show me again.
At 20?
So
Here
I
is
want to
20.
say something about 36, sir, because if I count from the 20 there, sir, then I come by 2 by the block.
By 4, yes. So let's go with 36. Remember, it's our judgment. If we want to say 36, good. No problem. Let's go with 36. So if it's 36, that's the cumulative frequency. So if we're going with 36, no problem if you go with 35 or 36. So go with 36, that's a cumulative frequency. Then the actual frequency for this group is what? 24, right? Agree with that?
Yes, sir.
Then now add 36 to 42. So 36 plus 42, that is giving us 78. That means when we got 30, we're supposed to get 78. Just double check to make sure we're not doing any mistake. Double check it, got 30, we're supposed to get 78. So we stay so now,
So the
boom.
last one would be 34.
Oh, because this not giving us, if we got 30, is that giving us 78? Actually giving us 76, don't? If you look at 30, it giving us what? 76 or 78? How much it give us? At 30, how much is this? That's 76, right?
26. They say content 4.
76.
Very good. So since it gave us 76, then it couldn't be 78 here. It should have been what? It should have been 76. And if this is 76, then this can't be 36. How much you said this should be then? 30, how much?
No, I was talking about 41 to 50. You when you put in the frequency.
Oh, 41 to 50?
Right.
Oh, don't jump down there yet. Look what I'm saying though. Before we reach down here, remember our graph is giving us 78, right? Well, actually, the computation would give us 78, but the graph is giving us 76, right? And if you take 42 from 76, that means this number actually should be 34. We want it end up balancing, and this number should be 34. And if this number is 34 and this is 12, then our actual number here should be 22. Cool? It have to add up to get a 200. Now add 84 to the 76. How much this gonna be now? 76 plus 84. That's 160, right?
Yes.
Now that we get the 160, now we can go to the next part. Now the next part, we've got to know the 50 and see what we get. So now we'll go to 50, bring it up. 50, we already know 50 was the 196. So nice. So now we do the subtraction part and we get to our 36. Oh, that's what you mean when you say 36. Yeah. Yeah, you're right. Yeah, you were just skipping, no problem. Then of course, this is 2 bills. Now we're good to go. Remember now we multiply f times x. These two will multiply now. So now we multiply 15.5 times 42. That's 651. So we'll multiply 45.5 times 36. I guarantee the next thing they're gonna ask you to find is the mean.
Sir, I thought it was the 15.5 times the 22.
Repeat.
I thought it was the 15.5 times the 22.
15.5 times 22. Go. Let me see. 15.5 times 22. Oh, 341, right?
Right.
That's crazy. I get 351. Thank you. 341. Then we multiply finally 45.5 times 36. And we get to our 1638. Now, once we do that now, we can go ahead and use the information. I guarantee they're going to ask you to find mean. To find mean now, we just need to remember one little formula. The amount of time I tell you to remember one little formula, but that's how it is. You have to remember mean is the sum of fx over the sum of f. The sum of fx would be add up f times x. Add up all of these. So we add up 66 plus 341 plus 1071 plus 2982 plus 1638 plus 222. Then all of that we divide by the sum of f, and the sum of f we said was 2 bills. We'll divide it by 200. Then we'll put that in the calculator. Put everything in the calculator. It's just 2 marks. You're not getting any marks to show them a whole heap of step. So put all of it in the calculator. 2982 plus 1638 plus 222. Then we divide it by 200. And of course, we get our 31.6. Now, just 31.6 minutes. Now, always remember this. Key thing, remember this for me. Only going to say it one time. If you work out and you get a number, but it's very far from the median, just know that it might not be correct. The mean, the mode, and the median are usually close together because those are what we call measures of central tendencies. So if you get let's say you get 57, check it over. If you get 65, first and foremost, it stop at 60 minutes. So if you get 65, you know something off right there. Off by the rip. So in that case, you know you must get an answer first and foremost between 1 and 60. Second thing, your answer must be close to the median. So if the median is 33, anywhere from about 25 to 35 is good. But if you're outside, or maybe say 25 to 40. But if you're outside that, then you need to check over. Statistics fin. Now, question 6. Question 6, this usually tests questions like volume, total surface area, area of a circle, area of a triangle. That's pretty much question 6. All right. Question 6 deal with them stuff there in geometry: volume, perimeter, total surface area. That's number 6. Then question 7 is going to be a pattern question. 6, you don't change. All right. The format of the paper. So here them tell us use pi as 22/7. And then they tell us that ln and MP is both 49 meters. And then now they tell us that LM and NE and NP, so these right here, 98. So of course, on the inside, that is a rectangle. All right, cool. All right. Now them say show that the length of the running track is 350. In other words, show that the perimeter of this is 350. Now, the perimeter of this, all we really need to do is find the length of this arc right here, right? So if we find the arc length Ln, we know the arc length MP will be the same, don't?
Yes.
Right? Now, the arc length is really the circumference of the circle divided by the 2. So the arc Ln, we know it is the circumference of the circle divided by 2. But circumference is what? 2 pi r, then we divide it by 2. So this is pi r. Now, pi they said to use 22/7. Now, what is the radius? If the diameter is 49, then the radius, because that's how we have to use the radius. The radius would be half of that, which is 49 divided by 2. Then we put that in our calculator. So we put in 22/7 times 49/2. I'm lazy. I couldn't bother put the decimal. You put the decimal. I'm just being lazy. So the arc length is 77 meters. Now that we get the arc length is 77 meters, now we can find the perimeter. Now we can tell them, oh, the perimeter is going to be that 77 plus the bottom 98 plus the next arc length, which is 77, plus the top 98. And them say it should be 350. Punch it in our calculator and see. 77 plus 77 plus 98 plus 98 is, yep, 350 meter. Just a general knowledge question. What's usually the perimeter of a track?
400 meters.
400 meter, yes. So this is 350. We'd say that the track short 50 meter, but that's fine, right? It's a running track, and they didn't say it was for professional athletes or for high school athletes. Could be for primary school, prep school, we don't know.
Sorry,
Oh,
you can scroll back up 1 minute.
definitely.
All right, so thanks.
All right. Now, this part now, it says Nathan walks at a constant rate of 1.4 meters per second. So notice Nathan covering 1.4 meter in every second. Actually, Nathan is walking fast. 1.4 meter every second. Nathan is walking pretty fast. It says calculate the time it will take. It will take him to walk 7 laps around the track. Now, key thing they said is that he's walking at a constant rate. That means the speed at which he's walking is not going to change. So remember, the track is 350 meters. So first thing, find out how long it's going to take him to walk 350. Right? So we just do the division, right? So for the 1 lap, we just do 350 divided by the 1.4, and that would be divided by 1.4. And this is 250 seconds. So that's how long it take him to walk 1 lap. But him say him doing 7 laps at that pace. The 7 lap now is going to be 7 times 250. And that is going to be 250 times 7 is 1,750 seconds. Now, I wouldn't suggest leaving it like this. I would suggest dividing it by 60 to convert it to minutes. So it would take him actually 29 minutes, and this is 29 times 60, and we subtract it from that, leave 10 seconds. So it would take him 29 minutes and 10 seconds to do him 7 laps. I would convert it to minutes and seconds. It look better. So him just go walk, right? Some people hear them say, oh, I'm going to walk for 30 minutes. That's what Nathan doing. But that is crazy. That is crazy. Now it says part B, Tafari runs 1 lap around the track in 68 seconds. So Tafari is slow, right? I'm kidding. Tafari is not slow. So Tafari take Tafari run 1 lap. So him take, by the way, 68 seconds, right?
1
Yeah,
minute,
that's 1 minute 8
8
seconds.
seconds.
And we know that to run 350, oftentimes professional athletes can take about 39 seconds. So yes, we can conclude Tafari is very slow. And Tafari probably sprinting out him hard. Now, I don't like this question. Why? Let me tell you why I don't like this question. It says, determine the number of laps Tafari can complete in 1 hour running at the same speed. First thing, can you run at this speed for 1 hour? Absolutely not. So this is not a real
No,
life
sir.
question. This is absolutely ridiculous what is CSEC doing. You cannot run at this speed for, let's say, more than 5 laps. So this is stupid. So if you take him that to run 1 lap, he's not going to do it for an hour. What is CSEC doing? But the first thing I would do is for 1 hour, how much, all right, can you give me a second, please?
No
Let me
problem.
take
Yes,
a
sir.
thought. Thank you. All right. All right. Sorry about that. As I was saying now, how I would do it is convert 1 hour to seconds first. If I convert 1 hour to seconds, 1 hour is actually 60 minutes, and 60 minutes is 60 times 60, which is 3,600 seconds, right?
Yes, sir.
So now we're going to divide 3,600 by 68. I'll divide it by 68 because it takes 1 lap to the 68 seconds. So 3,600, 52 point, how much?
52.9.
52.9 laps. Now, that is crazy. Look what I'm saying. This 60, just ask a stupid question. Imagine you run a lap in 68, and let's say you do it for 10 laps. You're running for 680 seconds. And then you're going to continue the 10 more laps, right? You reach that now. That's 20 laps. Double it. 1360. And you reach 40 laps, right? And to run for 3,600, that is so stupid. This is a stupid question, very stupid. But that is what they said. Determine the number of laps he can complete. By the way, it says can complete. The 0.9 him don't complete yet. So much laps him
Oh,
actually
yeah.
complete.
52.
So 52 laps completed. Just to Don't lose any mark. 52 laps completed, which absolutely makes no sense. Now, here's what they say now. It says Nathan completes running 1 lap around the track every 72 seconds. Tafari and Nathan started running at the same time from point L on the track. Each completed a number of laps of the track. It says calculate the least number of laps that each will complete before they are both at point P, at point L again. So no problem. Basically, it's asking when them gonna meet up back, and they're gonna meet up back when Nathan do what? Lapping. Nathan gonna eventually, not Nathan, Tafari gonna eventually do what? Lap Nathan, don't?
Yes, sir.
So that's all they're asking. At what point in time they're gonna end up meeting again. So Tafari going around at every lap 68. So just if you get an idea what's happening. So see it here, them run around the track, right? 68 seconds. This is Tafari in the 1 lap. Let's say when Tafari is here, Nathan is 4 seconds behind. So this would be Nathan after 1 lap. After another lap, Nathan 8 seconds behind after 2 laps. Then Nathan 12 seconds behind after 3 laps. Then Nathan 16 seconds behind after 4 laps. And eventually at some point, him gonna get lapped, and so him gonna get lapped and then end up reach back at L, right?
Yes, sir.
That's all. All right. And they want to know how much laps Tafari complete and how much lap Nathan complete at that point in time when they actually meet. So let's set up our equation to do that. So first thing is we know the amount of time it takes Tafari to complete a lap. So it takes 68 seconds, right? And we don't know. All right, it takes 68 seconds. Now, the best way I'm going to do it is actually use distance. All right, I'm going to use distance. All right, I'm going to equate their distance to be the same. So first and foremost, what's a linkage between distance? What's a linkage between distance and time? Let me see if anybody remember. What's a linkage between distance and time? That's the formula I want to use, so it's way easier for me. All right.
Sir, what do you mean by
All right, so no problem. So we know this formula. Velocity is distance divided by time, don't?
um
Velocity is distance divided by time. Look what I'm saying. So if bolt covers 100 meter in 10 seconds, we say that bolt is running at 10 meter per second. That means for every 10 meter, it take him 1 second, don't?
yes, sir.
So if you take him 10 meter per second, that's how him run the 100 meter in 10 seconds, don't? Because it's taking him 10 meter per second. So first thing I'm suggesting is we find the speed at which both athletes are running. All right, we're going to use a distance equation, and we know when they meet, of course, it's just that one of them 1 lap ahead. All right, so that's one way we can do it. All right, everybody, by the way, understand that method that I'm suggesting?
Yes, sir.
Yes, sir.
All right, just want to make sure for clarity. All right, just want to make sure for clarity. All right, and again, you don't have to do it that approach. You can, of course, do some other algebraic approach to it. But I like when we're doing it that way because we're going around a. Remember, the track is, they say was what? We have to bear this in mind. It's a 350 track. All right. So we need it to work out to be some finite value when they end up meet up back again. So we know that it's a 350 meter track. All right. And let's call the number of laps n. All right. So the number of laps n for Tafari. So Tafari do n laps. All right, so Tafari, the n laps. All right, and erase the stuck. Tafari does n laps, so Tafari does n laps. And when Tafari does n laps, we know that Nathan supposed to do n minus 1 lap. So that's how them gonna meet up back at the same spot. Nathan do what? N minus 1 lap. Him gonna do 1 lap less. But what we do know is that their distance is going to be the same. Well, actually, their distance, well, Tafari distance is going to be 350 more than Nathan distance, don't it? So if Tafari cover X distance, Nathan supposed to cover X minus 350. Agree with that? This is their distance. Right? You agree with this?
Yes.
Now, after we set up that now, we're going to set up this equation now to solve for X. Now, remember, distance, right? Remember, distance, how we find distance? Distance is velocity times time. Distance is velocity times time. So first we need to find their average velocity. Let's find their average velocity. So the average velocity, remember, the average speed, this is how we find average speed again, like this. Nathan, is the same Nathan? So Nathan was walking at a constant speed of 1.4 meters per second, right? So all we do is how long it take him to do a lap, right? So let's find the speed up here first. So remember, this is for Nathan, by the way, right? Let's put it separate. Nathan's speed in distance 350 divided by 72. I'll plug that in the calculator to get him average speed. So 350 divided by 72, and we get this amount, which is 4.861. All right, I'm going to keep this. Let me keep this fraction. All right, I'm going to keep the 175 over 36. All right, there's a reason why I want to keep the fraction, because I don't want to get any rounded off value and rounding off laps.
So, sir, which button on the calculator you press to change it into
Oh, to
decimal?
decimal, press SD. On the calculator below the cosine, to the SD, press SD and get the decimal.
Oh, sir, probably that one new calculator you have.
Oh, oh, you don't have this calculator?
Nope.
So
That
your calculator
option.
give you straight decimals.
Yes.
Oh, I know which one you're using. You're using 82 MS. Look at the top.
Yeah.
See MS. Yeah, so you're using the outdated calculator. That's
So
like from
me have to get that one then, because that
Yeah,
easy
oh,
for me right now.
Thank you.
yeah. You're using the outdated one, man. Some 2004 calculator, that man.
Yes, really, sir. That
Yeah.
calculator is easier to use.
Easier, way easier. So this is the speed at which he's running, 175 over 36. If you want the decimal, it's 4.86 meter per second, right? That's his speed that he's going at. So he's covering roughly 5 meters every second, all right? All right. Now, at this point in time now, so Nathan's speed is this 4.86. No need to work out now Tafari's speed. Tafari's speed is going to be, of course, 350 divided by 68. I'll work that out. 350 divided by 68, and that is giving us
5.1.
5.15 roughly, or you might say 175 over 34. All right, 175 over 34 meters per second. Now, remember, we're stating that they meet when their distance, they meet, of course, when this happens, when Tafari is 1 lap ahead of Nathan. But remember, X is velocity times time. So we're saying they meet when the velocity 175 over 36, that's the velocity, times some time, right? We don't know what t is yet. We're gonna deduce what is t, all right? But look how we're gonna deduce what is t now, right? Look at this. So 175 over 36, right? Over 36 times t. This is for this is x for this is x for o. Tafari equal to now. This is the distance equal to now. He should be one lap ahead of Nathan. All right, he should be one lap ahead of Nathan, and Nathan is 175. Oh, wait, this is who? 175 over 34. Remember using the fraction. It's easier for me. 175 over 34t equal 175 over 36t minus, of course, 350. Then now we're going to solve for t. That gives us the time at which now both of them going to meet. But it's going to give us the time, of course, for Tafari. All right, so solve for t now from this. No problem. Let me show you this calculator special. Bring over, so we have 175 over 34 t minus 175 over 36t equal negative 350. All right, so now this is 175 over 34 minus 175 over 36. Plug that in the calculator. That is 0.28. 0.28
Sir, that we
t,
get to, sir.
0.28 t, and oh, this should be a Nathan 350 behind. Put plus there. Sorry, that should be a plus then. I'm 350 meters behind. So now 0.2859 whatever equal 350. So all we're going to do is divide 350 by this. So divide by, or 350 divided by that. So that is at 1224. 1224 seconds is when they actually meet up. 1224 is when they actually meet up. But 1224 seconds, we need to deduce how many laps that. The question basically don't know at 1224. Look at this. 1224 divided by, I don't want to be subtracting 72 so much time. So divide by 72. That's when Nathan does 17 laps. We see it? So when Nathan does 17 laps, that's when they meet up. And so Tafari should be at 16 laps. Let me times it back by the 72. All right, divide by Tafari time for the lap is 68. Oh, yes, it's right. Tafari does one more. So at the time when they meet up, Tafari does 18 laps and Nathan does 17 laps. All right. So notice all we did. I know this question, let's be honest, this question was challenging. It's difficult to remember this equation. Distance is velocity times time, don't? So this kind of challenging because we had to remember this equation, and oftentimes again, this is not so much taught. This is more so interpreted, right? So that's all. Remember, we'll get the time we'll solve for t. We'll set up this equation. I will solve for t. After we get t equal this, all we did was divide each now by the amount of seconds to get each person laps. All right, so we divide 1224 by 68 for Tafari, and we divide, that tells us that Tafari the 18 lap in that time, and then we divide 1224 by 72, and that's how we get the 17. Just to put it there for those who want to use it for revision purpose. Cool? We okay with this?
Yes, sir.
All right, so that was a nice question. Then, of course, number 7 is the most boring question on the paper because this is pattern. Now, I absolutely cannot draw a pattern, so you make sure you can draw and get your full marks. The good thing is we're on the computer, so it's not that bad. Notice this is a square with 1, 2, 3, 1, 2, 3, area 9. This is going to be 16, this is going to be 25, so oh, it should be what? Oh, it should be what? Area is 9, area is 16, area is 25. What should be our area?
So how
What
you
should
do it though?
Oh, all I'm saying is the
Sir,
length
32.
3 by 3. This is 4 by 4. This is 5 by 5. So our area should be what?
6 by 6.
6 by 6, which
Yeah,
Oh,
is
what's not going
36.
to what's not going to details like that? We like
36.
just sheet 6 I think and 6 and next one
yeah,
like 6
I know.
plus 1 6
Yeah, I
like
get
that.
you. I get you. I say it a little bit different. So yeah, so we just go 6 now. 1, 2, 3, 4, 5, 6. Then 6 go up. 1, 2, 3, 4, 5, 6.
Oh, sorry, that's an shade it.
No, I'm gonna shade it like how they shade it now. Just drawing the square
Oh,
first.
oh.
1, 2, 3, 4, 5, 6. Am I at 6? 3, 4, 5. No, I'm at 6. And then I go up 6. 1, 2, 3, 4, 5, 6. Then I go across. Then I go down. Then now I'm gonna have to shade it how they shade it. Catch a pattern, they go across entirely. So you're gonna have to shade going across. I'm gonna use, they use black or gray or whatever you want to call that color. So 1, 2, 3, 4, 5, 6. Don't laugh at my shading. The next thing I notice is the shade, the top row going across. So now you shade it going across. Of course, I do it neater than I. And that's it. Cool.
Yes, sir.
That was kind of tricky though.
The pattern was kind of tricky.
Yeah.
I guess so. Now, I guess next thing they always do is a table. Exactly. They always put the table. Now, when they put the table now, no problem. We just follow the pattern. Following the pattern, put your bracket right here. Right? Notice right here, they say number of colored squares. First thing I want you to do is write down the formula down here. Before you do the question, write down the formula. I'm going to tell you why. The formula always saves lives. Notice to go from 5 to 7, it increased by 2. 79, it increased by 2. Straight away, put 2n here. So now, notice 2 times 1 would give you 2. 2 times 1 would give you what? 2. But we need to reach 5. So we're going to add 3 to it. So you put 2n plus 3 is the formula. Check if it works. It works all the time. Look at this now. In the second one, 2 times 2 plus 3 is what? Isn't that the 7?
7.
Yes, sir.
And 2 times 3 plus 3, that's what? Clearly 9.
Yeah.
Yes,
So
sir.
then, so when it's 11, just plug in as what now? 11. So 2 times 11 plus 3, that's
25.
22 plus 3, 25. It always works. The formula always works. So if you even want to check to see if you answer the question right, remember you just did the one with 6. So you could put in 2 times 6 plus 3. That's 12 plus 3, 15. We're supposed to shade 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wait, let that again. I make sure I don't miss none. Because they shade 1, 2, 3, 4, 5, 6, 7, 8, 9. For hours, plug in our 4. That's 2 times 4 plus 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes, we get to our 11. Notice we get 11 when we plug in 4. It was figure 4, don't? 2 times 4 plus
Yes, sir.
3. We get the 11. So actually verify say our formula is right.
Sir.
Yeah.
Um.
But we get the 2n plus 3.
No, sir. I'm just there ask you if in right beside the 49 so we ask you if that a 46.
49. Oh, if n is 46,
Yeah.
can't be 46. So if this is 49 now, and you know the formula, you set the formula now equal 49. So 2n is 46, so n must be 23. You forgot to divide by the 2.
Sir, I'm foolish with this, I said. We have a 23 for the something I say, you know.
Yeah.
Sure, sure.
So 23. All right? Yeah. Now, catch the pattern now for the perimeter. What it go up by? What's going up by? From 12 to 16.
Sure,
What's it going up
4,
by?
4,
4. So
Four.
put 4 right here so first, then n. Then which number plus 4 give 12?
sir, repeat what you say, sir.
Which number plus 4
Eight.
give you 8? So the formula is 4n plus 8. Cannot go wrong. So easy. First thing, you just look at the change, write down that number times n. Then, of course, 4 plus which number give us 12? Done. So now that we get the formula, right? Look how we know so formula, right? Even plug in 11. 4 times 11, 44 plus 8, see there, 52. So no, correct. Now, to get this one right here now, we just need to plug in n as 23. So here, so work out 4 times 23 plus 8. I think that's 92 plus 8 is 100, right?
Yes.
Now, we need to work out now the total number of squares. Now, this was just 3 square. Notice when it's 1, it's 3 square. Notice when it's 2, it's 4 square. When it is 3, it's 5 square. So when it's 11, it's just what? 13 square, don't? Notice it's 2 more. So
Yes, sir.
169.
169.
Good. So notice when it's 23, add 2 more. So when it's n, you add 2 more. So the formula is n plus 2 square. Easy, don't? This pattern question had a little bit niceness to it because we had to be doing some deduction, right? Cool.
Yes, sir.
Now, this question now, it says, how many white squares are in figure 11? So look at figure 11, right? First thing is, we know the amount of total squares, 169. So if we subtract the colored squares, 25, that must give us white squares or the plain squares, don't? Now let's put that in the calculator. 169 minus 25, and we'll get 144, right? Good with
Yes,
that?
sir. Yes, sir.
Yeah, no problem. Oh, nice. And guess what? Section 1, finish. Section 1, finish. No, section 2 now. Section 2, I'm not gonna lie to you. If I didn't say this, I would be lying. Section 2 is usually the harder of the two sections. Make sure it's section 1 good. Because the number 9 and 10 usually can come tricky. Number 9 and 10 can come tricky. Now, number 8 is going to be nice. It's either linear programming and relations and functions or quadratics. Now, number 9 is circle theorem, trigonometry, bearings, and question 10 is vectors and matrices. That's a 9 and 10 can come tricky. We want to maximize our marks for number 1 to number 8. So start question 8 here. Functions. It says simplify g of x minus 2 in its simplest form. Now, if that asks us for g of 1, everybody know you plug in 1 square minus 5, where x is you put 1. So g of x minus 2 mean where x is now, we put x minus 2. So so g of x minus 2 is where x is, we put x minus 2 square minus 5. But we don't finish it. They say simplify it. So you're going to have to multiply x minus 2 times x minus 2, then subtract 5. X times x is x squared. X times negative 2 is minus 2x. Negative 2 times x is minus 2x. Negative 2 times negative 2 is positive 4 minus 5. So this is x squared minus 4x Then the 4 minus 5 is minus 1. That is it in its simplest form. That wasn't bad. Good with this?
Yes, sir.
No, not bad at all. Now the next one say, find F inverse of 11. I'm going to show you the two ways to do it. Now, anytime they ask you for F inverse, that means the Y value is this amount, F inverse 11. The easier way to do it is to solve F of X equal to 11. They're telling you the Y value is 11. So in that case, they're going to say F of X is 4X minus 1 equal 11. Add 1 to it, 4X equal 12. Divide by 4, X equal 3. The rule you need to remember is if
Sir,
F,
sir, what are this, sir?
I'm writing down the rule, man, so you don't follow. This is a rule. If F inverse of X, let me write it down. Let me start from the function part to the inverse. So this is the rule. If F of X is equal to N, then it's the same as saying F inverse of N is equal to X. If F of X is equal to N, then F inverse of N equal X. So they gave us F inverse N. So all we did was plug our N as, our N is what, 11? Or solving for X. This is the rule we use. Now, this rule is often not taught, but I teach this rule. Now, if you didn't know that rule, let's scratch that. Scratch that, method 2. What a lot of persons going to do for 2 marks, which I think is too much work for 2 marks, what they'll do is say f of x, 4x minus 1. So to find the inverse, we interchange x and y. So say x is 4y minus 1. Make back y the subject. X plus 1 over 4 is y. So that's our inverse. Then after we get our inverse now, to find f inverse of 11, we'll plug x as 11. So 11 plus 1 over 4. 12 over 4, which is 3. This is
Hold on
method.
this, sir. Hold on.
Are going too fast?
No, sir, we never know say you could actually do it that easy way like that.
Exactly. So I'm telling you the way I do it first. This is not taught. So I'm telling you the rule now.
See, well,
Why?
that we are working for today.
Which
Yeah,
one?
definitely. Definitely. All right. So this is another way it can be done, but no problem. If you use the method too,
So,
that's
sir,
fine.
it can be done in any case, right? Right.
Any case, any
All right,
case.
sir.
Once you set to evaluate inverse, just set the function equal to the value. Done. Easy.
But the
Sir,
first
scroll up a little bit. Sir, scroll up a little bit to the question. Uh, all right.
Yeah. All right.
Sir.
All right. Now, this part now says determine the value of h of 1. That means you put 1 in h and then you do it again. So first thing we realize h of 1 would be where x is, we put 1, that's 3 to the 1, and 3 to the 1 is 3. Now once we get 3, we need to find h of 1. Well, we just work out h of 1 is 3, so now we need to find h of 3. So where x is now, we'll put 3. So 3 to the third power, and 3 to the third power, I believe, is 27. And then we'll finish. Easy 2 marks, all right? Not necessarily easy 2 marks, but good little 2 marks, all right?
Yes, sir.
Good little 2 marks. Nice. All right. So that was functions. Now this is quadratics, and they give us the quadratics in the form of a graph. Now here them say now complete the table. Notice to get the, all we need to do now, f of x is y. Always remember, f of x is y. So all I'm telling us to do is to complete the table. When x is -2, plug it in the calculator and find the y value. So when x is -2, y equal. That's what the table is saying. Put in a calculator. So put in, of course, -2 square plus, well, actually minus -2 minus 2. Put it in the calculator. The y value we get is 4 right here. So we get 4. Plug in 0, you're going to get -2. 0 squared minus 0 minus 2 is -2. 2 marks for that. Always 2 marks to complete the table. Easy. Then,
Oh,
of
wait,
course,
sir, hold on, sir.
Yeah.
Sir, we can do a cover or you get it 4.
Oh, I put the -2 in the calculator here. So -2 squared minus -2 minus 2. That's how I get the y value.
All right.
Yeah, and use a calculator, right? Don't try to check it by hand. Sometimes we'll make a small mistake. Calculator now gonna make the mistake. Now, it's of course we need to complete the table and plot the graph. Oh my, the more we plot a graph. So 4 marks to plot the graph, 2 marks for these points. They're so boring. They say use a scale of 2 centimeters to represent 1 on both axes. So first thing, label it. 2 centimeters represent 1. 2 centimeters represent 1. 2 centimeters represent 1. So I have 1, 2, 3. This is now -1. This is now -2. 2 centimeters represent 1. 2 centimeters represent 1. 2 centimeters represent 1. 2 centimeters represent 1. Going down, -1, -2. Now we need to plot the points. So going back, -2 to 4 is the first point. So -2 is x, and y is +4. So -2, +4. Then we have -1 to 0. Then we have -0 to -2. Then we have 1 to -2. So 1 to -2 is here. Then we have 2 to 0 is here. Then we have 3 to 4. X is 3, y value is 4. Then now you draw your smooth curve. Now, I am the worst at drawing quadratic curves, but I'm going to try. You're going to draw your curve, making sure it passes through all the points then. So I'm just trying a thing here. I can't draw a curve. Gonna go something like this. All right, not too bad. So notice from my graph, the minimum point is something like, this look like half, and the y value is -2.5. All right, so that would be your quadratic curve. 4 marks for that. Another time they could ask you to complete the square and actually tell them these values. Remember, these values is -h and k. Sometimes they tell you to put it in the form a in bracket x plus h square plus k. All right, so this recording now is continuing the January 2023 paper. So you probably would have noticed now I was in a live class and the time ran out for the session. So I'm picking up after I had my dinner and feeling rejuvenated to finish 9 and 10. Now, question 9 and 10, it says WXY, WXU are points on the circumference of a circle. TV is a tangent to the circle at U. UW is a diameter. And it says WXU is an isosceles triangle. Using appropriate theorems, state 3 reasons why, explain why measure of angle Z is 45. So let's go ahead and do that. So the first thing, they told us W is a diameter. So the first reason I would tell them is since W is a diameter, since W is a diameter, then remember triangle formed in, this is what? Angles in a semicircle is 90. So since W is a diameter, then WXU is going to be equal to 90 degrees. And this is by angle in a semicircle. Angle in the semicircle is 90, right? So this is half of the circle. Angle in the semicircle is 90. Since it is 90, and we know that W UX, angle at U, is going to be equal to W Which one is that? That is UWX. They're both going to be equal to the same since it is isosceles. And since it is isosceles, therefore it must equal to also 45 degrees because angle in a triangle add up to 180. Reason number 2 now is angle at the center is twice the size angle at the circumference. So we know that angle W, the center, the angle, they didn't give the center a marking, so let's not call it anything. Let's tell them angle at the center, angle at center is equal to 180 degrees. And so that implies angle at the center is twice the size angle at the circumference, which implies angle at circumference, and angle at the circumference is WXU, that's going to be 90. Since that is 90, that implies that, oh, by the way, I didn't finish why Z is, since this angle on the inside of the triangle is 45, we'd have to subtract out now to get the 90. I hope everyone would have picked that up. And then now, right here now, since we have this is 90, we can tell them now that WUX is equal to UWX, and that is going to be 45. Reason number 3 now, finally, to finish it off is because now angle between a tangent and a diameter is 90. Angle between tangent EV and the diameter, angle between tangent and the diameter, W is equal to 90 degrees. So that implies, of course, then, that implies that, of course, that the 45 degrees plus Z should give us 90, so Z is 45. Those are our reasons, and we're good to go. This one now, they want us now to, of course, find angle X and Y. And they give us a bunch of information. I don't read it. Oftentimes I just look at the diagram, even though it's not drawn to scale, and jump straight into their question, right? Just to save time. Angle X now, we need to find X. Notice that this triangle here, the triangle E whatever J, EJ and whatever they would call this point, if you notice the other triangle is basically the same triangle, it's just that the orientation is different. So this angle 56 and this angle X, they're equal, it's just that the orientation is different. It's just that this is bigger, but it's basically the same triangle. So X is equal to 56 degrees, alright? And they call it again, angles in the same segment of the different triangles are equal. That's it, so that's 56. Now once we get that X is 56, then we can find this angle now, because angles in a triangle add up to 180, so I'm going to call it R. So we know that R plus 56 plus 19, that should be equal to 180 degrees. So if we transpose it now, so 180 minus 56 minus 19, and that is giving us 105. So R is 105. Now we can find Y, but Y is equal to 180 minus R because the angle's on a straight line. So 180 minus 105 is 75 degrees. So angle Y is 75 degrees. Nice. That's it. So 56 and 75 and we're done. Moving along, the next part now, they give us this triangle and they tell us there's a vertical post RT at R. So once we're at R, we have some vertical post, right? So we have some vertical post. Alright, I know it don't look vertical, but this is vertical. Alright. Alright, this is the vertical post. And then so the angle of elevation from Q. So angle of elevation from Q to the point T, they tell us this is 21 degrees. So basically we have our right angle triangle there. Alright, this is 90 degrees at R. This is T, this is Q. This is 21 degrees. And they told us that QR is 153. So what they gave us the adjacent, and we're trying to find what? Find the height of the post. This is RT, and we're trying to find the opposite. When you have opposite and adjacent, you use tan. So tan 21 degrees is equal to our opposite over the adjacent 153. So in that case, we cross multiply, and the opposite, remember, is our distance RT. So RT is 153 times the tan of 21 degrees. So in that case, we plug that in the calculator to get the height. So RT is equal to 153 times tan 21. Punch that in, and we'll get 58.7 meters. Once we get RT is 58.7 meters, let's say given that the length QS is 135, find the perimeter. So they tell us that I like to highlight it with my ruler. This is PS, and they told us, of course, that PQ is 83, and they told us QS is, this is 135. Alright, that's what they just gave us. Anytime you have two sides and an inclusive angle, you use cosine rule. So cosine rule tells us that the unknown side square, so PS square, is equal to the first side square, the 83 square, plus the next side we know square, so 135 square, minus 2 times the first side times the second side times the cosine of the angle between them. And the angle between them is 29 degrees. So in that case now, we just have to work it out. 83 square plus 135 square minus 2 times 83 times 135 times the cosine of 29 degrees. I'll put that in and we get that amount, PS square equal 5,519. Then of course we square root it, so square root this amount. I'll get PS equal 74. I'm gonna round off since I noticed they're giving me these straight values. So PS is 74 meters. So now the perimeter now, so the perimeter, we did all of that just to find PS is 74. The perimeter now of PQRS is just adding the total distance around. So we'll add the 74, the 83, the 153, and the 110. So that's all as I say. We'll add the 74, we add the 74, 83, the 153, and the 110. And we'll put that in our calculator to get the perimeter. I will add them, I will get 420 meters. That's the perimeter. And question 10 is finished. Question 11, it says now, explain why the matrix product is not possible. QS. So this is Q and this is S. Notice the order of matrix Q is 2 by 2. And the order of matrix S is how many rows? 1, 2, 3. It's 3 by 2. So why is it not possible? It's only possible if these two, I always do it this way and circle them, these two numbers should be the same. So that's why it's not possible. So we can tell them since the number of columns of Q is not the same as the number of rows of S, then we can tell them QS is not possible. That's the reason. And we're done. Now it says state the order of SR if we multiply S and R. Notice S is, of course, 3 by 2 and R is 2 by 2. So notice these are the same. So therefore, the result of S times R is going to be these numbers that leave back. So the order is a 3 by 2 matrix. And we'll finish. It says calculate the matrix QR. So let's calculate the matrix Q times R. So Q times R is equal to multiply 2 times minus 1, 4, 3 times the matrix R, and the matrix R is 1, 6 minus 5, 4. We'll multiply them, we'll multiply row by column. So remember, it's going to become first row by first column, alright? So multiply those. So it's going to be 2 times 1 plus negative 1 times negative 5. Then for the next element, now we go first row by second column. So multiply 2 times 6 plus negative 1 times 4. Then of course we multiply now 4, 3 by 1 minus 5. So we go 4 times 1 plus 3 times negative 5. Then finally now we go, the last one now is 4 times 6 plus 3 times 4. I will simplify that. Put this in a calculator, 2 times 1, then plus negative 1 times 5. You put that in, that should give you 7. 2 times 6 is 12. 12 minus 4, and I believe 12 minus 4 is 8. Then 4 times 1 is 4. And then 3 times minus 5 is negative 15, and 4 minus 15 is negative 11. And 4 times 6 is 24. And 24 plus 12 is 36. And that would be a matrix product QR. Once we get the matrix product QR, now they say, given that A is this matrix, determine the value of X. So we have to remember that this means determinant symbol. So the determinant of A equals 5. So they're telling us 4 times X. Then we have minus negative 7 times negative 1 is equal to 5. So 4x minus 7 is equal to 5. So 4x is equal to, add 7 to both sides, we get 12. Then we divide both sides by 4. X is 3. So that's the value of x to make the determinant be 5. Easy. Part C now. Part C, they say in the diagram below, it says OPQ is a triangle. And it says ARB and AOQ are straight lines, and B is the midpoint of PQ, and R is the midpoint of AB, and OR to OP is this ratio. And let's hear what they ask. I don't like read so much, but no problem, you read it. Let's just jump to it. I like to just put on the diagram. I like seeing the numbers. They tell us OP is 4A, so from O to P. Right, they tell us this distance is 4A, and they tell us O to Q, and they tell us from O to Q this distance, from O to Q, they tell us that distance is 8B. I like putting that on the diagram. Then they tell us, of course, B is the midpoint of PQ, so this is B in the middle, and then they tell us R is the midpoint of AB, and they give us that point. So now, of course, they say find vector PQ. To go from P to Q, right? To go from P to Q, we can go from P to O, and then we go from O to Q. Going from P to O, right? Going from P to O is negative 4A, plus going from O to Q is 8B. So our answer is 8B minus 4A. Now, once we get PQ, all right, once we get PQ, we'll find that's 1 mark. We need to find now vector PR. Vector PR is, how is it that we can go from P to R, right? No, how is it that we can go to, how is it that we can go from P to R? So in reality, what we say, to go from P to R, right, using some known directions, we can go from P to B and then from B to R, right? So we're going to go P to B here, then we're going to go B to R using direction that we know. So in that case now, we can go from P to B, and then of course we can go from, well, why I'm doing it the longer way, that's one alternate, and then we can go from, of course, B to R. We're going to do it the two ways. That's one way. Or alternately, another way we can do it, I'll write it down here as well. To go from P to R, right? I'm not doing any long way. To go from P to R, we can go from, see here, to go from P to R, using what we know, this is the ratio we know that OR to RP is this, right? So we know that PR, notice if all of this is what? RP, they say is 3, and they say OR is 1, right? So what we're saying then is that going from R to P, going from P to R is just 3/4 of the total distance. Going from R to P is 3/4 of the distance of going from O to P. So it's 3/4 of OP. So 3/4 of vector OP and vector OP. Remember, what was OP? 4A. All of that was 4A. So it's 3/4 of 4A. So going from P to R is just 3A. Right? That's it. Going from P, well, just to make sure I have my signs right. Alright, going from P to R is this way, going from O to P the other way. So of course, I left off my sign. Going from P to R is 3/4 of going from P to O, 3/4 of going from P to O. Put your sign correctly. Alright, so it's -4, it's -3. That's the answer. Now, let's say you wanted to do it this longer way, right? Doing it the longer way is going from P to B. And going from P to B, B is the midpoint of PQ. Since it's a midpoint, going from P to B is going to be half of PQ. So here this is half of going from P to Q, plus now going B to R. Now half of PQ, remember we said was, this was PQ 8B minus 4A, plus now going from B to R. But going from B to R, what did they say about R? They said R was the midpoint, R is the midpoint of going from A to B. Now we'd have had to know now how to go from A to B. Now going from A to B, was that a given? Going from A to B, was that given? Or did we actually find out going from A to B? No. So since we didn't know, we didn't find this out, I would suggest don't use this method, right? Because then we're giving ourselves too much work. All right, don't use this method. All right, so we'll scratch this and we'll stick to the method we did it below. Please, just to save ourselves a lot of time. So saving ourselves a lot of time, we ended up working with going from P to R is 3/4 of going from P to O. So it was 3/4 of minus 4A, which worked out to be -3A. Next thing now is going from R to B. Going from R to B, right? Going from R to B. To go from R to B using what we know, go from R to B, we can go from R to, we can go from R to P, plus we can go from P to B using what we know. Now what is RP? RP is minus PR. R to P is minus PR plus vector PB. Now this is now minus PR. Remember PR, we just deduced that PR was negative 3a. So minus 3a plus vector PB. Now what is vector PB? Looking at the diagram going from P to B, we said going from P to B was half of going from P to Q. So that is now plus half of going from vector P to Q. This is now positive 3a plus half of going from P to Q. And P to Q, remember, is 8b minus 4a. So working that out, that is now 3a plus half of 8b is 4b. Half of 4a is minus 2a. Then 3a minus 2a is a plus 4b. And we're done. That's our answer. And so now the paper finish. Remember this section 3 of this paper, I wouldn't have done it in a live session, but I add it to the live session part of the video. Alright, and so that completes the January 2023 paper. Very fun, very, very, very fun. Alright, read it.